So in the previous video, we said that elements are made up of protons, neutrons, and electrons. Let's talk about some other terms that are used when discussing atoms, particularly terms that are associated with numbers of protons, neutrons, and electrons. So when we talk about the atomic number for an element, the atomic number is always, forever amen, equal to the number of protons of that particular element. If you have your favorite periodic table in front of you, or the one that I've given you in class, the atomic number, or the number of protons, is the number that is above the element symbol in that square. So for example, hydrogen has a 1, so it has 1 proton. Travel over to the right-hand side to helium. Helium has 2 protons because that is its atomic number. Okay. What defines, and I have this down here, what defines an element is its number of protons, is its atomic number. If you look at the periodic table, you see that the atomic numbers, the numbers above the element symbol in the periodic table, those are all unique. Okay. So atomic number equal to the number of protons for a particular element. For the atomic mass of an element, if you remember from the previous video, we said that the majority of the mass of an element is due to the numbers of protons and neutrons, because those are a lot heavier than the number of electrons. So the atomic mass, sometimes called the mass number, can be calculated by adding the number of protons and number of neutrons for an element. If you look at the periodic table, the atomic mass, or the mass number, is the number that is underneath the element symbol in the periodic table. Now, when we talk about how much an element weighs, we talk about it in terms of this funky unit called atomic mass units, or AMUs, sometimes also used as U as a symbol. Don't need to know exactly how that relates to a unit that we're used to dealing with in the lab, like grams. Just know that when talking about masses of elements, the unit is atomic mass unit, and that number is on the periodic table underneath the element symbol in its little home on the periodic table. So atomic mass, atomic number, number of protons and neutrons can be found from that information. We can also use a shorthand notation, which is shown here, when writing information about an element with regards to its atomic number, atomic mass, and if there's a charge associated with it. So many times, particularly when dealing with elements that have a charge with them or different numbers of neutrons, chemists will use this mnemonic to write what the shorthand notation for a particular element is. So just the important parts here, what stands for X here, that is the symbol of an element. We're going to talk in the next video about symbols of elements. As a superscript on the upper left is the mass number, that's equal to the number of protons and neutrons. The atomic number, the number of protons, is a subscript on the left. And if there is any charge that is associated with the element, if it's a cation or an anion, then that charge would be listed here. This symbol does not have any charge to it, so it's a neutral charge. Things that are neutral charge have equal numbers of protons and electrons. So I've got 2 examples down here. We're going to do some more examples in a previous video, but looking at this symbol of AU, which is gold. This particular atom of gold has an atomic number of 79, so it has 79 protons. The atomic mass is 198, and I can find the number of neutrons, since the atomic mass is equal to protons plus neutrons. I can find the number of neutrons by subtracting 198 from 79, which we got from the number of protons down here, to get 119. So we're going to do some examples of how to calculate numbers of protons, neutrons, electrons in a subsequent video. What we will do next is talk about the symbols that are used on the periodic table for particular elements.